So hello everyone, welcome to the Open AGI Forum. I'm Eric Wong from CSDN, and today live from the GOSIM China 2024 in Beijing. We're honored to have Josh Triplett from the Rust project to join us. So he's got plenty of experience to share. So welcome Josh. Please take a brief introduction.
By all means, Shisha, I'm very happy to be able to participate in this. So I'm Josh Triplett. I'm a member of the Rust Programming Language Development Project. I'm a member of the Language, Library, and Cargo development teams, so I help shepherd the direction of the language itself, the standard library, and the tools used to package and compile Rust. And I've been working on Rust for almost 10 years since just after Rust 1.0, and it's the most fun project that I've ever worked on. I really enjoy doing it, and I love all of the people that I get to work with and collaborate with.
Your PhD research focused on scalable concurrent programming. So how has this background influenced your work and the perspective in the Rust project?
So a few different ways. So the work that I did in my PhD was about how to build data structures that scale to arbitrarily many CPUs. And when I was doing that work, getting a hold of even 64 or 128 CPUs was very, very difficult. Now you can rent those from the cloud for a few dollars an hour. And so concurrency has become quite a bit more important now than it was at the time that I was doing that research. And at that time, it was much more difficult to do scalable concurrency. Now with technologies like Rust and other languages that treat concurrency as first class, it is much easier to write concurrent programs than it used to be. Implementing the underlying primitives needed for that, implementing scalable data structures is still a challenge, but then those are made much more widely available to people to just use and reuse, and it is a matter of minutes instead of hours or days to successfully implement something concurrent using Rust or similar. And so it's given me a great appreciation for how much Rust brings to the table to make concurrency so much easier, because I've gone through an entire dissertation worth of how difficult it was to do in C.
So can you provide specific examples of how research has directly informed the design or implementation of Rust features?
Sure. So in terms of my own research, I know that there are a few people out there who have used the RCU-style development techniques in the Rust-based concurrency algorithms. They've also used other related techniques like hazard pointers and similar. In the broader sense of how research has informed the Rust language, I like to think of the Rust language as being a fusion of the best cutting-edge ideas from programming language research with some very practical ideas of how to get that widely available. So there have been research in academic languages and papers for a very long time talking about things like region typing and how to track the lifetimes and ownership of memory and similar. And Rust took a lot of those ideas, along with ideas from OCaml and ML and Haskell and many, many other languages, and put them in something that is very widely available and optimizing for being easy to use, even if you're not a reader of one of those academic papers. And I think that making those tools more widely available is a big part of actualizing that research, making it something people can really use. So I'm really happy to see how many research ideas come from academic research and end up in Rust. And now it's coming full circle with many researchers successfully doing PhDs and papers and professorships and similar built entirely around their research and development on Rust.
I see. So as a core Rust developer, how do you balance your personal technical interests with the overall needs of the project? So have you ever encountered situations where these two were in conflict?
So that's a great question. I don't think they've ever come into conflict, but I think it's a core part of open source that we have a lot of driving forces for what we choose to spend our time on. And it's never a good thing to use like what you most care about or what your company cares about or similar to make decisions without regard for the broader community and what they need. But it's perfectly reasonable to take what you're excited about or what your company's excited about and use that to prioritize what you choose to spend your own time on and what you choose to try to develop and work on. And the net result of thousands of people working on the thing that they're most passionate about is a project that a lot of people are really passionate about. So I care a lot about build systems and build time. So I spend time trying to make Rust build a little bit faster or find ways to handle more concurrency or similar. I care about asynchronous programming because I work on a lot of projects that involve async. And so I try to make async in Rust a little bit better, just because it helps to have the practical knowledge from trying a real world project rather than you don't want a group of language designers who don't regularly use the language they're designing. So I don't think they come into conflict. I think it's purely that what we're excited about drives what we spend time on.
So is there any story or any time your personal interests have conflict with your project or the work you want to do?
I don't think so.
So
no.
it's just your work is actually your personal interest.
So I have a couple of different pieces of things that drive my work. So I'm a contractor for Future Way Technologies, and I, in large part, what they tell me is, so what do you think Rust needs? I tell them, and they say, okay, you should do that then. Like, I really get very little, you know, oh, here's our agenda for Rust. They're just, our agenda for Rust is making Rust better. What do you think Rust needs to be better? As for my own personal interests, I have a startup company that I'm working on build system services, and that largely just leads me to write a lot of Rust code and push some of the cutting edge of Rust. And when I run into rough edges, I report bugs like anyone else. I try to get them fixed like anyone else. I contribute in the areas that I'm feeling passionate about. But I don't feel like those have ever come into conflict now.
So you conducted in-depth research in both the Linux kernel and the WebAssembly. So how do these seemingly different domains cross-pollinate your technical thinking?
Quite a bit, actually. So working on the Linux kernel and other very low-level components that are very close to the hardware and to the metal, and for that matter, I've worked on firmware and BIOS and bootloaders and similar. And that gives me a lot of insight into how does a language sit on top of the processor and the hardware? How does it make use of lots of cores or the instructions that you want to be using? What kind of code does it generate? And so it makes it easier for me to look at the lowest level of what code generation looks like. For the Linux kernel in particular, I've been incredibly excited about the Rust for Linux project because it makes it easier to contribute to Rust. People have written incredibly complex drivers much more easily. The author of the graphics driver for Mac OS systems, or rather for Apple Silicon systems, has specifically cited the Rust for Linux work as making it so much easier for them to build the graphics driver and much more easily and safely than they otherwise could have if they had to write it in C. And so I'm excited to see the rules that you had to very carefully follow or things would go horribly wrong, and if you're lucky it would crash, and if you're not lucky it would mysteriously corrupt things. When you're writing code in C in the kernel, encoded into the Rust type system where the compiler can tell you if you got it right or wrong. As for WebAssembly, I'm really excited about the idea of portable computation, about the idea of taking code and running it anywhere as reasonably efficiently as you can. My background there is that I followed the ASM.js work that predated WebAssembly, and then I participated in the Chrome native client work as well. And that was exciting in the sense of giving the web technologies to run code fast and native, but not very exciting because it tied that to specific hardware architectures, x86 or ARM. And so the idea of having a portable layer like WebAssembly that is reasonably fast and works everywhere, I think that provides the perfect scripting language for anything where people would previously embed JavaScript or Python or Lua. I think embedding a WebAssembly interpreter now makes sense to let your program be scriptable, or your game or your application to make that scriptable. And again, the idea of balancing low-level access to the hardware with portability like WebAssembly, how do you get those as close together as possible? And Rust is all about, do you want this or this conflicting goal? Well, here's how we can do both. So WebAssembly is how we can do both.
You have been pursuing a vision for building system optimization for 16 years. So can you share how this long-term goal has impacted your personal and professional development?
Sure. So there's two aspects of that are really important to me. One is that people spend a lot of time waiting on software to build. And if you think about the process of developing software, it's very much a scientific process of, like, you have an idea, you do an experiment, you wait for the results of that experiment, you use that to decide if it was the right experiment, and you try again and you iterate. And you have an idea, you write it down in code. That's the point where, you're using your ingenuity to try to turn that into code. But once you've written that, now you want to test it and get a result. And that's not a point where you can just sit back and think about the problem as much. It's where you're eagerly waiting on the results so you can figure out which part of the problem to think about. It's the worst possible time for a delay. So you're spending 5 minutes, 15 minutes, 30 minutes, an hour waiting on code to compile. This is completely ridiculous. And we have such huge amounts of processing power that we should be making that more readily available to compile code. But it's a hard sell to say, oh, go spend, $10,000 buying a high-end workstation for all of your developers. It will make them more productive. It will be worth it. But it's a very hard sell to a business saying, oh, spend this amount per month and you get access to all of those CPUs in the cloud and whatever the fastest build hardware you can get and share it among people makes a lot of sense. So I want to make people wait on builds less and spend more time coming up with great ideas, testing them, and rapidly iterating. And then the other half of it that I've been thinking about for going on nearly 2 decades now, I really want people to be able to build software out of many different components. And every project I've worked on has roughly had this need. I think Cargo and other modern build systems come closer, but they're still like, Cargo is designed to build Rust code. People sometimes shoehorn it into building C code that's embedded in a Rust crate. But if you want to combine 20 different types of resources, whether they're code or other types of software resources or imagery or 3D models, want to combine code written in 5 different languages, compile them all together and make a software image you can deploy or an executable installer or similar. It's really hard to do that, and every company reinvents this with their own in-house bespoke build systems or with a few open source ones that are trying to solve this problem, but not really in a cross-language, cross-platform way. So I'm trying to make it as easy as possible to assemble a lot of different components reproducibly into a piece of software. And I'm using WebAssembly to glue all of that together as the way of scripting your build.
So as a former lead software architect for Chrome OS at Intel, so what insights did you gain from the transition from closed to open source? So how has this experience influenced your current work approach?
That's a great question. So in that role, I dealt a lot with the difference between Chrome and Chromium, where Chromium is the open source version of Chrome and Chromium OS is the open source version of Chrome OS. And so usually there would be 90% open source and then they sprinkle a few proprietary components on top of that. And there's always this tension where people tend to push to want everything that they are consuming to be open source and then keeping as much of what they're doing secret because they think it's critically important and nobody else could possibly reproduce it. And so you have these systems where almost all of the drivers are open source, but we couldn't possibly tell you how this camera works because then you might reproduce that and take what we're thinking we're providing value on. And you have a whole array of different groups that feel like, we're providing unique value that nobody else could possibly duplicate unless we give them our source code, but everybody else should share all of their source code so we can just use it. It's a tension where the happy medium is almost all of this should actually be open. I feel very strongly as a result of that work that a lot of the innovation there is make a camera whose hardware is really good, make a processor whose execution and whose cores are really, really good, make a laptop that's really powerful. If you want to be different, if you want to have something unique that people are paying for, build a technology that's actually better, as opposed to, well, it's just as good, but we don't tell anybody else how ours works, so it'll slow them down. I really like it when people don't have to reinvent the wheel, and for going on 3 decades now, the reason I've cared so much about open source is the fact that people don't have to reinvent the wheel because people share how it works. You can spend more time innovating on the cutting edge and less time duplicating what other people have done. And at the same time, people also need to get paid. And we can't get our work done if we're not well supported and have a secure environment where we can get that work done. And that implies having sufficient financial support. And it is sometimes hard to build a business around open source. And so people have that tension of, well, what do I share and what do I not? If you're a hardware company, it makes a lot of sense to say, well, we're sharing all of our software to drive that hardware because we want to make more people drive the hardware. But if you're a pure software company, it's hard to build a 100% open source business. I think it's valuable. I think it's really important. I think it's a huge contribution to the world. I also understand that people have to balance that with, if it's 100% open source, maybe the business isn't viable and can't ship at all. So if people have to say, hey, this piece of it is proprietary so that I can make a living, I can understand that. It's reasonable. I think if you're going to do that, the one thing that's really frustrating is when people say, well, it's almost open source and we're going to start calling it open source, but it's not actually open source. That's a really frustrating recent trend where people use a almost but not quite open source license and call it open source. That one's incredibly frustrating. If you want to be proprietary to drive your business, be proprietary, be proud of it, say, okay, this is our secret sauce and we're not sharing so that we can make money. Just don't call it open source if it's not.
How do you really avoid reinvent, do the things people have done again? Because all the programmer, and I think most of programmers, they have self-doubt. And after the AI AI compiler come out, I think the self-doubt has becoming more stronger.
That's a really fair question. So a lot of people do suffer from things like imposter syndrome and similar, where it feels like, oh, all these people around me are smarter than I am and I'm just barely keeping up. One of the principles I think it's really important to remember is that we see everybody else's highlights while we know our own complete story. So for ourselves, we feel the good days and the bad days, the days that we feel really productive and the days that it feels like, do I actually have a brain in this head? And for everybody else, we see them posting about this cool thing they did. We hear about them talking about it. We talk to our colleagues and they say, oh, here's this fun thing that I worked on. We see people's status reports and cool software they publish. So for the most part, we see other people's highlights and we compare their highlights to our ups and downs because we see our ups and downs and not theirs. That's a big contributor to things like imposter syndrome. And so it's really helpful to normalize people writing about, here's something I tried that didn't work and here's how it went horribly wrong. Here's this debugging adventure I had. Here's this, way I spent 8 hours debugging a 5-minute mistake. I like normalizing things like that, of showing the full story to people, and it helps people realize, hey, we all have our moments and we all have our, less than brilliant moments. And that helps people overcome that. Beyond that, this in specific regard to AI and how that can affect things, it can be really amazing to watch AI come up with a piece of code that looks like, oh wow, that did hours worth of work in minutes. There's a study that just came out, I think it was in the last month or so, talking about how productive people are if they're using AI for assistance. And what it said was, people feel more productive using AI. They aren't actually more productive using AI assistance. They feel more productive. And this is really consistent with a lot of the things about reinforcement learning with human feedback, RLHF, where are we making things that are better, or are we making things that are more convincing to humans? And we have trained AI code assistants to make people feel better about writing code, which is not the same thing as making them more productive writing code. Now, that doesn't mean we couldn't. I think AI absolutely could make people more productive writing code, but it's possible that so far it might have been trained to make people feel more productive writing code. So it's worth keeping in mind AI is doing a decent job of making things that look like plausible code, and that's what it's been trained for. And possibly one day it will write things that are good, reliable code that are as good as humans, but I'm not particularly worried for my job as a programmer anytime soon, and I don't think brand new programmers should be either. I think that AIs make mistakes that humans never would, and vice versa. Like, different types of mistakes, different types of dealing with things. Beyond that, I think that we have a lot more things to worry about when it comes to AI than just, it replacing new developers or new users or unskilled programmers or similar, in terms of hopefully we can get it aligned with humans a little bit better first.
So what specific action have you personally taken to foster an inclusive and positive open source community? So what challenges do you think still need to be overcome?
It's a wonderful, wonderful question. It's something that matters a great deal to me. So when I first got involved with Rust, one of the things that I noticed was that it was surprisingly easy to get involved. And that was true in a lot of ways. They had an open development process when it came to here's how language changes or library changes are made. You post an RFC, you iterate on it, you talk about it with people, you incorporate feedback, eventually it gets accepted. And having that open process and makes a huge difference. And when I started working on that process, and then I felt like the people involved in Rust at the time, which, I was a brand new Rust user, just barely getting involved with development, it felt to me like the leads of Rust and the members of Rust teams spend time helping new users and time bringing in new users at the expense of some of their own work and their own priorities. They spent a lot of time mentoring people, a lot of time reviewing other people's work, a lot of time helping people iterate, in preference to, I'm just gonna sit down, heads down, and write code and not pay attention to other people. And so I've strived to emulate that and to bring that forward to the next generation of Rust programmers. I spend much more time reviewing other people's proposals for Rust than making my own. I spend much more time iterating on designs with other Rust team members and with Rust community members than I do trying to push any of my own goals or designs. And I feel like that has a multiplicative effect. One of the expressions I really love that I've used in a number of places, people talk about the mythical 10x programmer, the person who can write code 10 times better than anybody else. And that exists, it's a thing. But at the same time, I think the best way to be a 10x programmer is to make 10 other people twice as productive. And you've just created 10x more programming. That is the only way you will ever be a 100x programmer or a 1000x programmer or a 10,000x programmer, is by making other people more productive. And that has a multiplicative effect that one person will never match. And that matters so much to me. So I've worked on helping other people, bringing other people up to advance people in the Rust organization, to help people become more productive and get their work done and learn how to contribute, as well as trying to make our processes more approachable, because as Rust becomes bigger, as so many more people care about it, it gets very busy and very hectic and very complicated, and our processes can be a little hard to approach sometimes. When I got started, it was easy to just write an RFC from scratch and iterate with people. It took a lot of work, but it was straightforward. Now, you might want to have some conversations first of, is this the right direction, before I spend a lot of time writing an RFC? I might want to write an initial proposal, do an experiment. We try to make some ways to test your ideas, test your hypotheses, and get a little preliminary feedback, get a vibe check on what you're doing before you spend a huge amount of time. Because I don't like the idea of people wasting 10 hours doing something that someone in 5 minutes could have told them, you might want to try this direction. It's worth the expert taking the 5 minutes to say, try this, and then they take 5 hours working on that, and then the expert can take some time saying, yeah, that looks right, let's do that. I get very frustrated when people say, I'm doing all of this work, I don't have time to mentor new people. You'll never have that time, you'll never get new people, and you'll always be busy if you don't take the time.
I feel that. How do you view Rust's application in different areas such as systems programming, web development, and embedded systems? And which area do you think has the most potential?
So Rust started out, and its brand is still very much one of we're a language to make system programming easier and similar. And I think that is critically important. When Rust was coming up to 1.0, they made a lot of really momentous decisions that look even more brilliant in hindsight than they were, done fairly quickly at the time, but now they seem incredibly important. Rust took out its runtime environment. It used to have, much like Go and some other languages, an asynchronous runtime that was kind of running underneath the language, much like a Java virtual machine or the Python VM or Go or similar. And that got ripped out, the whole green threads runtime and similar, the user space scheduler. And some other details of it, like garbage collection, got ripped out, not because they had a brilliant idea of this is the specific direction we're taking the language, but more they're very complicated systems. They were doing a 1.0 of Rust, and they wanted to commit to stability forever, and they couldn't commit to those things. And sure enough, 10 years later, we haven't stabilized some of those things, so I think that might have been the right decision. But even more importantly, there are a lot of languages out there with runtimes. There's not a lot of Rusts out there. Rust, by making those decisions, became not just a language that was competing with Go or Python. It was a language competing with C, and nobody was trying that. There's an old quote I saw once of if you want to look for the languages that have tried to replace C, history is littered with their corpses. A lot of things have taken a run at C. Not many of them have done as well as Rust has in that regard. And that's made Rust uniquely positioned for you can write firmware, you can write OS kernels, you can write web browsers, things that are much harder to write in a managed language, a VM-based language or similar. So that's always going to be a space that Rust is particularly well suited for, anything that your next best choice is C or C++. At the same time, and that's also true for the web as well, Rust is an ideal language for writing WebAssembly because you don't have to bring a runtime along. So you can write Rust and end up with a few kilobytes of WebAssembly instead of a few megabytes of WebAssembly. But I also think Rust is trying very hard to be a universal language as well, that there will always be things Python's a little better at. There will always be things that JavaScript is a little better at. But we are trying very hard to be a language that works reasonably well for anyone and then has some areas we're especially good at, rather than saying, oh, that area we don't care about at all, we're going to leave it to other languages. We're not wanting to leave things out and say that's not our domain. People talk about well, what will the successor language to Rust look like? What, if we choose to not cover a given area, what language will take that area from us and then run with it? And a quote from one of my fellow language team members, Travis Cross, he goes by TC, he said, Rust is its own successor. And especially with the addition system and similar, Rust strives to be the language that follows on from Rust every time. We're continuing to make it better. We don't just draw a line and say, we're done now, because saying that we're done is saying we're going to start dying and making room for the next round of languages. And we're not ready to die yet. We'd rather keep going.
So what's the thing, are the unique aspects of the Rust community culture? So as a core developer, you do help shape and maintain this culture?
Absolutely. So I think Rust has always, from the beginning, as a result of the people who were involved in it and what they cared about, prioritized how to treat people, how to include people. It's been a core defining ethos of Rust. It has been a standard advertised feature of Rust that we try to have a very welcoming and inclusive community. We don't always succeed perfectly. We don't make any claims to be perfect. We make claims to keep getting better. And we're never going to be perfect. We're always going to strive to be better. But I like to think that Rust always strives to be on the leading edge of that, where other communities now are where Rust was 5 years ago or where Rust was 10 years ago. We're trying to drive the cutting edge where there are leading edge technologies that are trying to be more inclusive and welcoming. There are ones that are around the industry average, and there are ones that are less inclusive and less welcoming than average. And we're trying to blaze that trail. And as a leader in Rust, a big part of that is demonstrating what you want others to do. Like I said earlier, I felt included when I joined Rust, and I strived to emulate that for others. And so people spent more time trying to mentor me. I spent more time trying to mentor others. And you demonstrate what you want to get. But I think that's especially true as Rust grows, because all projects as they grow are going to have a tension between the people who started it and the culture that they started, and the tendency of things that are exposed to the entirety of society to regress to the mean, for want of a better description. And so as more people show up to Rust with an attitude of I'm just here to get my job done, and don't necessarily start out caring about the values of the Rust community of being inclusive, being welcoming, treating people decently, then there could be a tendency, if we didn't make a deliberate effort, to just kind of regress to the baseline of how the software industry treats people on average. And we make a deliberate effort to try to stay a little better than that, try to push that leading edge. And sometimes that means reminding people what those values are, trying to notice when things could be done a little bit better, as well as just demonstrating what we expect, and by trying to be exemplars of it and whenever we can. And so any project that doesn't make a deliberate effort to maintain and evolve its culture as more people come in will lose that. And I think we've made a deliberate effort to try to improve that culture, but to try to keep and preserve that culture rather than having it regress.
Yes, you just mentioned you want to build Rust as a universal language. So how do you view what is the biggest challenge you have encountered to promoting Rust adoption in more companies? How do you address these challenges?
So I think there's two that I would highlight as the leading challenges Rust faces. One of them is that adding Rust into an existing organization means it needs to play nice with others. As much as there are frustrating memes about the Rust evangelism strike force and similar, which is really obnoxious, and for anybody who feels like they are trying to evangelize Rust in an aggressive way, you are not helping us, please don't. The meme of rewrite it in Rust is kind of damaging. And from scratch rewrites of things are not always the right answer, and are often not the right answer. If you have a large, well-established C code base, you might want to start making plans for how you include Rust. You don't want to say, oh, we have to drop everything and rewrite it, even if that means more bugs in the short term. That's not the right answer. I don't want to aggressively have Rust replace other things. I want to have Rust play nice, have a way of adding Rust to your C project, slowly start migrating some of your C to Rust while keeping your test suite passing, keeping your users happy, and maybe, some years from now, your large project may be largely Rust or mostly Rust, but that's not a rush to do it tomorrow at the expense of stability and quality kind of thing. So one aspect of that is people realizing that and having ways of having Rust and C and C++ and other languages play nice. Rust interoperates pretty well with C. We have a foreign function interface for C, but we could be better. We could make it easier to say, hey, you don't have to run special tools to talk to C from Rust or Rust from C. We could have a C compiler built into Rust so that you compile your Rust and your C together and they can call each other very easily. This is something I admire in the Zig programming language, that is another language newer than Rust that has tried some different things from Rust. They're not aiming for the same degree of safety. Their big highlight is, what if C and Zig are trivially interoperable and completely and totally call one from the other with no effort? That's something I would love to achieve with Rust. That's something that people are making efforts to do, but it's going to be a little ways further off, and we'll have to do some work to get there. So that's one, is better interoperability so that Rust can drop in and play nice with an existing project and make it easy to do migration. I think the other challenge is that there is a constant tension between Rust trying to help you be safe, help you be explicit and similar, and give you sufficient control over things, versus Rust doing things for you automatically. So a lot of languages, Python, Java, garbage collected languages with a runtime tend to allocate everything. So if you want to make an object, you will allocate it and have a pointer to it. And this can be easier sometimes. You don't have to think about how long it's going to last. It lasts until you stop referencing it, and then you drop the reference and it goes away with a garbage collector. That makes things a little easier. With Rust, we will help you reference it where it is. You can do reference counting. You can declare everything in an arc or an RC. And I have a sticker on my laptop that says, keep calm and call clone. Like, you can absolutely clone things everywhere, use arc everywhere. This is not bad Rust. Please feel free to do it. You'll still end up with something that's probably faster than your average interpreted language, and you can always optimize later. So Rust makes it possible to make incredibly optimized code that borrows everywhere and allocates as little as possible. Rust does not make it mandatory to make incredibly optimized code that allocates as little as possible. You don't have to start there. You can start with using a lot of clone, using a lot of arc, using a lot of mutex, do profiling, find your bottlenecks. Oh, this little bit is slow, so we're going to try to allocate a little bit less here, but you don't have to start making it perfect. This is one of the reasons I used to be a Haskell programmer. I enjoyed that, but I got out of it because it was actually not very good for my mental health because it contributes to perfectionism. You can always make Haskell code more perfect, and it's really painful to just, at some point you have to actually ship something. And this is a problem that a lot of people in the Haskell community have. It's a very impressive language. I love it as a research environment, but for production purposes, you have to ship reasonably often and not just try to make things perfect. And Rust can contribute to that danger. So we try to make the language more usable. We try to make some things more automatic, but we have that tension between, do we hide something because it's complicated, or do we expose it so we give you more control? And as often with Rust, we're trying to say the answer is, well, both. But those are still in tension sometimes, and we constantly have discussions in the Rust language team of how much do we expose, how little do we expose, how easy can we make it. We're not as trivial to write as Python. We're not as trivial to write in the same ways because you have to think about things you don't have to think about writing Python. So we want to be as easy to use, but that's going to be a hard road to go.
Besides the C, Python, or Java, so do you have view Rust in relationship with other emerging systems programming language, such as the Go, and what can Rust learn from this language?
So we tend to have a pretty cordial relationship with a lot of languages. One of the things that Rust advocates is that we don't like to bash other languages. We will sometimes make comparisons of saying, what do we learn from this language? What can we do better? What aren't we doing as well? But we try not to be in a mode of bashing other languages. We try to be very friendly and cooperative and cordial with other languages because we have things to learn from them and they have things to learn from us, and we should keep a conversation going. There are some languages that we have particularly close relationships with. There's a lot of people who use Python and Rust together. There's a lot of people who use C and Rust or C++ and Rust together. But I've seen some amazing work interoperating almost any language with Rust just because Rust has an interface to C, and a lot of languages have an interface to C, so you can glue almost anything together. I think that there's been a real language renaissance starting a few years before Rust kind of kicked off that was driven a lot by LLVM, where the open source and permissive nature of LLVM that made it available to everybody suddenly made it so you can write a compiler front end and then use LLVM as your back end. And so writing a language became a weekend project instead of a lifelong endeavor. And so a lot of language experimentation started around the time Rust did. Some of those languages are gone now, some of them are still around, but it's wonderful that a lot of experiments are being tried, and a lot of we've had some wonderful conversations with the Zig community, like I mentioned. They've done several innovative things, including the C interoperability, as well as some stunts about dynamic linking with glibc that are very impressive that we would like to emulate. And I also hope that Zig one day provides ways of being safer, similar to what Rust is doing. Perhaps their sensibilities would be more like optional safety, but I hope that they provide a way of being safer. And so we have lots of conversations all the time with other languages. Our standard RFC process has a mention of prior art. What can we learn from other languages here? What have other languages done that we want to emulate or that we want to avoid? That kind of thing.
Great. So As an experienced open source contributor, so what advice do you have for newcomers wanting to start contributing to the Rust project?
Quite a few things. I think there's some very good guides online for how to do first contributions and similar. I would say there's two good approaches you can reasonably take. If you have something you're really passionate about, prioritize that. Like, there's nothing quite like somebody who really, really cares about something that's going to drive somebody to be persistent, to push past obstacles and similar. And so if you have something you're really passionate about, if you're learning Rust, even before you come to contribute to Rust, when you're learning Rust, it helps to pick a project that you are not finding business critical, like this isn't on anybody's critical path, so you can take your time, but that you care about and it's going to be interesting, and so go write that. In my case, it was a tool built around the Git version control system. That tool is mostly dead now, but it was a fun experiment at the time that I really wanted, and I wrote it in Rust because I wasn't in a great rush, and I used it to learn Rust, and I upgraded it as my knowledge of Rust got better, and I looked at some of the old code, and oh boy, that was terrible, but we all start out terrible and get better. And so pick something you're excited about that isn't super critical path and try experimenting. And then when it comes to contributing to Rust, either pick something you're really passionate about or pick something that is low-hanging fruit that feels like something you can do that feels relatively easy. A small contribution is a great place to start. Don't feel like you have to bite something off that's going to be really big, really important. Everything is important in some way, or we wouldn't be tracking it, we wouldn't be caring about it. And there's a lot of smaller issues where, yeah, it might be 10 lines of code, but it showed you how to contribute to the project, and it was an important 10 lines of code, and nobody else had done it yet. And 10 lines of code can make the compiler a little bit faster, can make things a little bit easier, can be actually a really fun one I would recommend if you're running the compiler and you find like, that was a really confusing error message, or that was like the compiler could have helped me a bit more there, like it told me this was wrong, but really this is what's wrong. Error messages in the compiler are a wonderful place to start. You find something that doesn't quite feel right where the compiler could have been a little more helpful. You send in a 10, 15 line patch that detects the situation. One of the nice things about Rust is like we try to make the compiler as fast as possible. We don't always succeed, but we're always trying. But then once you've detected an error, we decided, okay, it's okay for error handling to be a little slower. You're not on the go fast path. You're on the take your time and explain to the user what's gone wrong path. So once you've detected that something's wrong, figuring out the best possible error message, it's okay to take a little more time doing that. That's a great way to start contributing, and people see that error message and will go, oh, hey, that made my life much easier, and you'll save a bunch of people 30 seconds understanding what their problem was, or 20 minutes understanding what their problem was, and congratulations, you're now a 10x programmer. You've just made thousands of people very slightly more productive.
I see. So the last question, maybe you make a conclusion. So looking ahead 5 to 10 years, what do you think are the most exciting directions for the Rust language and the ecosystem? So what innovations would you personally most like to use? To see.
Absolutely, yeah. So Rust will definitely still be around in 5 years, 10 years, 15 years. We will ship some more additions. We will be evolving the syntax of the language, evolving the usability of the language. I think that we're going to resolve more of those tensions between explicitness and automation in favor of finding a better balance than we currently have, because our balance right now is almost all the way towards explicitness and very little towards automation. We're going to find ways to make it so that in most code, you shouldn't have to write a lot of extra detail to clone an arc or to deal with the mutex. I think that we will have something that feels like a scripty dialect of Rust where I say, you know what, I don't really care about memory allocation. Here's a convenient way to declare an arc of mutex. And that language won't aspire to be as fast as C. It will aspire to be like, instead of a better C, it'll be a better Python. And I think that we want to have that. We want to have a redeval print loop. There's been a desire for an official Rust REPL for a long time so people can experiment and try things. I think that we will have much better interoperability with C and C++. Today you have to run tools like bindgen and C bindgen. And I think what we will move to is a model where you drop C and Rust into the same project and you say, I have some C over here, I'd like to call this C function and it will just work. Or I have some Rust over here, I'm in C and I want to call the Rust from C, and Rust will just automatically generate the equivalent of a header file or similar. I think we should get to the point where you can say something.rs, something.c, compile them with the same compiler, and then they just work together the way that C, the way I would aspire to is think about how C++ interoperates with C. C doesn't have all the features of C++, it doesn't have classes, it doesn't have templates, but from C++ you can call any C function anytime. All you have to do is make sure that the header file had an extern C wrapped around all the functions. Other than that, you include a C header file, you call a function, it just works. That is, frankly, one of C++'s most important defining qualities is that it's perfectly interoperable with C. I want Rust to be that good. I want Rust's C interoperability to be as good as C++'s C interoperability, and that's really a high bar. That's how good we should handle C.
Well spoken. Thanks for your insight, Josh. So for the insightful discussion, and thanks to all the developers watching. So that's all for today's podcast. See you next time.